Hello guys, good morning. This is Maggi here, and now we are going to discuss about the calorimetry principle. So, calorimetry means it is a branch of thermodynamic which related to the measurement of heat is known as calorimetry. Okay, and the instrument whatever we use in this process or heat measurement is called calorimetry instrument. Okay, so in the calorimetry, here two bodies in which one is solid or another is liquid or both may be liquid. इसमें मेजरमेंट में क्या है कि दोनों में से एक सॉलिड एक लिक्विड हो सकता है या दोनों ही लिक्विड हो सकते हैं, इनको मिक्स करते हैं. सो लेट दिस इज सॉलिड एंड दिस इज अ लिक्विड. ओके, whose it is A and it is B mixed together, and its temperature is T1 and this temperature is T2, where T1 greater than T2. So we can say that this is the temperature of mix T mix whenever both substances will mix together. So here we know that Q equals to Sm delta T. So let its mass of this is m1, specific heat is S1, and temperature difference will be T1 minus T mix. In the same way, the second one is mass m2, specific heat is equals to S2, and change in temperature is equals to T mix minus T2. Here T1 greater than T2, so heat transferred from T1 to T2. Let in the calorimetry process and substance A which is solid and B which is liquid mixed together, whose mixed temperature is T mix. Here T1 is greater than T2, so temperature or heat transferred from T1 to T2 or body 1 to body B or A to B. So in this process using Q equals to Sm delta T. So according to the calorimetry principle, given heat is equals to taken heat. This is main solution of this calorimetry principle. So according to this, m1 s1 T1 minus T mix equals to m2 s2 T mix minus T2. So on the solving, m1 s1 T1 minus m1 s1 T mix equals to m2 s2 T mix minus m2 s2 T2. Okay, so it is equal to m1 s1 T1 plus m2 s2 T2 is equal to T mix कॉमन ले लीजिए, it will be m1 s1 plus m2 s2. so T mix will be m1 s1 T1 m2 s2 T2 upon m1 s1 plus m2 s2. It will be the mixed temperature. Okay, but will be solved by this. Okay, and now let me discuss here the latent heat. Okay, so what is latent heat? It is the heat required to change the state solid to liquid or liquid to vapor. Okay, so the heat required to change the state without change the temperature is called latent heat. Okay, so it is the heat required to change the state without change the temperature is called latent heat. And latent heat is in the two parts: latent heat of the fusion and latent heat of the vapor. latent heat of fusion and it is the latent heat of vapor. Okay, so first of all let me discuss here the latent heat of the fusion. Okay, so what is the LF? Latent heat of fusion. Okay, here Q, that is the latent heat, is equal to ml. Okay, so the value of N is equal to Q by M, or the unit of this is equal to calorie per gram, or we can also write the joule per kilogram, the unit of latent heat. And there are two types of the latent heats. First one is latent heat of the fusion, and latent heat, second one of the latent heat of vapor. So what is latent heat of fusion? So it is the heat required per unit gram. Okay, heat required in or 1 gram of substance from solid to liquid. It change solid to liquid. ये क्या करता है लेटेंट हीट ऑफ फ्यूजन में से कि चेंज द स्टेट। ये आप जानते हैं कि जो लेटेंट हीट है वो ऐसी हीट रिक्वायर्ड है जो स्टेट चेंज करने में रिक्वायर्ड होती है। तो अब यहाँ पर कौन सी स्टेट चेंज करने के लिए यूज होगा? इट चेंज फ्रॉम सॉलिड टू लिक्विड, यानी सॉलिड से लिक्विड में चेंज करने के लिए जो हीट रिक्वायर्ड होती है पर यूनिट ग्राम में, दैट इज नोन एज लेटेंट हीट ऑफ द फ्यूजन। एंड इट्स वैल्यू फॉर द आइस इज LF for ice is equals to 80 calorie per gram. Okay, so now latent heat of the vapor, this is LV, so it is equals to the heat required in per unit gram from लिक्विड टू वेपर। यहाँ पर जो स्टेट चेंज करता है वो क्या करता है? लिक्विड से वेपर में, इसमें चेंज करता है। सो इट इज द रिक्वायर्ड हीट इन पर यूनिट ग्राम फ्रॉम द चेंज द स्टेट लिक्विड टू वेपर इज कॉल्ड लेटेंट हीट ऑफ द vapor. Okay, and latent heat of the vapor for the water, LV for water is equal to 536 calorie per gram. इतनी होती है वाटर के लिए latent heat. Okay, so in this way we will solve both the latent heat of vapor and latent heat of the fusion.